Hi, good afternoon. Welcome to another one of our Thursday webcasts. My name is Brad Heuiser. I'm with Customer Driven Technologies. Those of you that are joining us for the first time, if you haven't used the GoToWebinar interface before, you'll see this little diagram below, sums it up pretty nicely. You have two options as far as listening to the audio, which if you're hearing me say this, you're probably already hearing me, but if for some reason you'd rather switch over to a telephone, there should be a dial-in number where you can call in and listen on the telephone instead. Anytime throughout the presentation, if you have a question, feel free to type it in below. We'll get to the questions at the end. We'll get to as many of them as we have time permitting. If you have any other issues throughout, you can click the raise your hand. But note that we will wait until the end of the presentation for all of the questions. Like I said, my name is Brad Heuiser. I'm the applications engineer for Customer Driven Technologies, based here out of St. Louis, Missouri. For those of you that are not familiar with CDT, you can kind of think of us like we're a value-added reseller of PTC products. So we're not directly under PTC, but we deal exclusively with PTC products, including Windchill, Creo, MathCAD, and ArborText. So a good analogy I know that Ben uses all the time is we're kind of like the Ford dealer. And if you want to buy 1,000 Crown Victorias, you can go directly to Ford Motor Company. But if you're only going to buy one, you typically have to go to a reseller, or in that case, a dealership. So we handle all of your service needs. You know, we'll sell you software. We'll do training. We do handle customer support as well. For those of you that, especially those of you that use Windchill, we do handle migration and integration services as well. We are now part of Barry-Wehmiller, a very large engineering services company based here also out of St. Louis. It's been almost a year now. We got taken over by them last February, and I will say it's turned out to be very nice. It's taken a little bit of the strain off of the company. You'll notice down at the bottom here under PTC Certified Training Centers that we have the same ones we've always talked about: Kansas City, Arlington, Texas, and St. Louis, Missouri. But you'll notice three more here: New Jersey, North Carolina, and Orlando, Florida. We're actually expanding. We recently acquired a company called Heuiser, and we're very happy to have those guys on board. That's all still kind of panning out now. We're also talking about adding, or in the process of adding, another training center out of Chicago, which I'm sure that being out of St. Louis, I'll spend a lot of my time there. And there's some more coming down the pipeline as well, which I'm probably not allowed to talk about. If you have any training needs or any training questions, you can find all of our training info on our website, cdtplm.com/training, and you can even register for classes directly there, or you can find us through the PTC training system as well. Note that we are a little unique in that a lot of resellers have class minimums. You must have 2 or 3 students or 4 students to run a class. CDT has traditionally always run students even if there's only 1 student in the class. So if you're worried about a class being canceled, don't worry about that. Just because you might be the only person, if there's some really off-the-wall crazy class that, or you want to do a custom configured class, we are always welcome to doing that. And especially me, I get paid by the day, not by the student, so I actually prefer the smaller training classes as well. So what we're going to talk about today is part 3 of the Advanced Assembly series we've been doing. I know I haven't done one of these since April of last year. With the acquisition, it's gotten really, really busy around here. Finally, it's starting to slow down enough we can get back into these. But we're going to cover, basically, we're going to dive a little bit deeper into the skeletons. I've been getting lots of requests for more information on skeletons. I touched this briefly last time, and we're going to get into this a little more. I've been getting a lot of questions about, well, how do you use skeletons? I know you talked about them, but I don't know how to apply those to what I do. Well, what we're going to do is we're going to dive in a little bit deeper into skeletons. First, I'll do a little refresher on what skeletons are, again, on top-down design methodology. And then I'll teach you guys how to use skeletons for space claims, how to use skeletons for placement references, how to copy models to a skeleton, and how to share skeleton geometry. Those are kind of opposite of one another. Copying models to a skeleton is where I take an existing part and I create a skeleton model from that part, whereas the opposite, sharing skeleton geometry, is where I take an existing skeleton and create a part from that. And then we're getting to something that's kind of cool that I like a lot, creating motion skeletons. And again, like I said, at the end, we'll get to all those questions and answers that you guys probably have. And you'll provide the questions, so hopefully I'll provide the answers. If you come up with something where you stump the chump, me being the chump, then absolutely, if I don't know the answer, then I'll get your contact information and I'll get that back to you. That being said, we should have a few poll questions. Rosalinda, if you wouldn't mind going ahead and throwing those up.
All right, then.
We definitely appreciate you guys filling these out because they help us target our webinars towards what you guys actually would like to see. And Rosalinda, if you wouldn't mind, let me know when you're done with those. And
Okay, I'm about to put them up. Here's the first one. Okay, I'm going to put up the second one. Okay, I'll give this another second, and we'll go into the last poll question. Alrighty then, I think that's gonna do it, Brad.
Okay, well, thank you very much.
All yours.
Okay, so let's start by talking about top-down design. This is a perfect example. This little powered, I don't know if you would consider it a kayak or a ski board or a combination of the two. Looks like they took a kayak and turned it into something else almost. But this would be a very good example of something that you might use top-down design on. What is top-down design? Top-down design is a methodology that allows us to put it in layman's terms, to capture the design intent of a design without having to know how all of the pieces of the puzzle are going to function. Like the example of the lawnmower in the bottom left corner, I don't need to know what size blade I'm going to use on the lawnmower before I place the seat in the proper location. I don't need to know necessarily even the size of the deck before I work on the engine. A lot of bottom-up design approaches are not. That is not the case. Let's say it's almost like the other extreme would be working with Legos. I've got a 4-year-old and a 1-year-old son, so there's lots and lots of Legos around the house. When they're building a house out of Legos, where the roof is going to be is very dependent on how many stacks of blocks you put in. Using a top-down design, however, I could specify a location where the roof would be and a location where the walls are, and I wouldn't have to know if I'm putting a green block or a blue block or any of that information at the time of designing the walls. I can do that later when I get to that portion of it. So it really has an emphasis on planning and a complete understanding of the system before you get into the small details. Another really cool thing that top-down design allows us to do typically is it allows us to break a large assembly or a large design into separate smaller pieces that we can dole out to different teams. So in the case of the lawnmower, I might have one team working on the deck, I might have one team working on the seat mounting portion, and one portion the frame, and then another team working on the engine and the transmission. When I have that ability, it greatly speeds up my design process because I no longer have one engineer telling me, oh, he's waiting. I'm waiting for Bob to get me the information back so I can work on mine. Then I'm going to hand mine to Jeff when I'm done with that. Everyone's concurrently working at the same time. So one of the most valuable tools for using top-down design is what we call skeletons. And again, this is one of those things that you will need the Advanced Assembly extension to use in Pro Engineer or in Creo. Skeletons allow us to do some really cool and unique things. Most commonly, people use skeletons for, like it says here, creating space claims for components, creating interface and placement references between components, and providing motion between components. So if you look at the example here on the right, I've got a skeleton for a very small one-cylinder piston engine. I've got 4 components represented here. In the light blue, you can see the housing or the engine block. I've got the blue cylinder on darker blue cylinder on top, designating the piston. There is just a sketch designating the rod between the piston and the crankshaft, and then I've got the actual crankshaft designated between a sketch and 2 cylinders and a couple of axes. That's pretty much all you need to capture the design intent of this mechanism. Now I can take each of those 4 components, I can pass them off to 4 different teams, and I can have a team working on the piston, a team working on the block, a team working on the crankshaft, and a team working on the rod. The really cool thing about this is that it allows us to capture the design intent of using the skeleton, and I then have the ability to change the design intent at the skeleton level. So one person can completely change the design intent of the entire design, and that will propagate downstream to all of the other teams that are working on this design, the portions of this design as well. A couple things about skeletons, just neat little things that help us keep track of them. They're always going to be the first thing in the model tree. So if I have an assembly that has a skeleton in it, I will see that directly at the top as soon as I open up an assembly. They have no mass, so if I add a skeleton to an assembly, or if I add multiple skeletons to an assembly, I will know that note that it does not actually change my mass properties of the assembly or at all. And then they typically have a bright blue color associated with them. Now you notice that there's a lighter blue associated with the skeleton defining the block. In this case, that's because it was actually given some transparency, so you can kind of see through it. And like it says down here below, skeletons are typically defined using different datum features, and a lot of times you'll see that they're not even solid geometry, they're just surfaces even. So these 2 diagrams really give one of the most beneficial parts of skeletons here. If you notice, on the left would be a traditional assembly. I've got, let's say my piston, my rod, my crankshaft, and my block, A, B, C, and D. I've got components D and component C that are assembled to component B, which is assembled to component A. At any time, if I decide I needed to come into a drastic overhaul of component B, or maybe delete it entirely, I wouldn't be allowed to do that without breaking some references. Now, the cool thing about skeletons is it assembles everything to the skeleton. So if you look on the right, you'll notice that A, B, C, and D are all assembled to the skeleton and not to each other. So now I can complete one of these portions and not wait for the input from a different member of my team, or from not have to, if someone makes a design change, then I don't have to worry about my thing suddenly being in the wrong, my portion of the design suddenly being moved to the wrong location or something like that. So another thing another little analogy I've heard always is think of a skeleton like a Christmas tree, and your design being all the ornaments and the Christmas lights that are on the Christmas tree. I don't have to assemble the ornaments to each other, even though I technically could, or the tinsel or whatever. The tree itself holds up all those ornaments. I can remove any of those ornaments without worrying about the other ornaments not being constrained properly. So here's what we're on to now, the actual demonstration. We've gotten a lot of feedback from you guys in the past, and the one thing that's common we find is most people don't like the talking so much as they like the actual presenting of the software. So let's flip over to Creo Parametric here. And one thing I will note is that very little has changed in the Advanced Assembly extension between Creo 1 and Creo 2. So even though I did parts 1 and part 2 of this Advanced Assembly extension using Creo Parametric 1.0, that everything should work almost exactly the same in Creo 2.0. So if you were looking to see what's changed from Creo 1 to Creo 2, I'll just tell you right now, not very much at all. So the first thing we're going to do is we're going to start and actually create an assembly using a top-down design approach. So let me first go in and we'll set my working directory to a location here that will allow me to create a few things. I'll make sure I'll start with a fresh slate. So the first thing I'm going to do is I'm going to create a new assembly, and I'm going to name that assembly drill. I'm going to create a real simple drill. And we'll design this guy in millimeter kilograms. And you'll notice as soon as I start this, my model tree has nothing in it except for drill.assembly. I can turn on the tree filters. You can see that I've got I've got some planes and a coordinate system that are in there, but those are really not going to be used a whole lot for us right now, so I'm actually going to turn those datum features off, which will allow us to see just the components and the other features that I add to this assembly. So when you use the top-down design approach, typically when most people create assemblies, they create the components separately and then they bring them together and assemble them. Well, with a top-down design approach, I'm going to actually create all of those parts from within inside this drill assembly. So let's say that my drill is going to contain several components. I'm going to start by creating, let's say first we're going to create the housing. So I'm going to say part housing. Notice when I do that, I'm going to be asked to pick, copy from an existing, or where I'm going to copy from as far as the parts. I want to make sure that I do pick my millimeter kilogram second part. And here I have the option to leave component unplaced. The first one I'm going to actually place, so I'm going to leave that checkbox cleared because I want the first component to be assembled using a default constraint. So as soon as I drop that in, I right-clicked in the graphics window and picked the default constraint. You'll see that put a default constraint in here, which, as we all probably know, assembles the coordinate system of the assembly to the coordinate system of the component that I just inserted into the assembly. If I turn my planes on, you'll see I've got one component inside of this assembly. Then also within inside of this assembly, I want to insert several other components as well. Let's say that I want to create another, let's say this time I'm going to do a sub-assembly, and we'll call this drivetrain. Because this drivetrain subassembly is going to contain all of the components, the motor and the gearbox and the chuck and that sort of thing. And I'm going to click OK. This time, however, I'm going to have to browse over to my assembly there, and I'm going to have to, instead of actually placing the component, because this component hasn't been defined yet, I'm going to leave this component unplaced. Now notice when I do that, and I'm going to zoom in and show you a little bit closer view of it here, that housing and drivetrain, even though they're both technically empty part and an empty assembly, they have different icons associated with it. So I can look at an assembly, my drill.assembly, and I can see housing part I created. It is assembled. It is placed in the assembly. Whereas drivetrain I also created, but it's got a different icon associated with it to designate that it is not actually assembled, or it's not actually placed into the assembly. Then one thing I'm going to do is I'm going to also create a trigger mechanism for this. So we're going to actually create this as a shortcut. We're going to say trigger and create this as one single part. We'll also leave this component unplaced. And let's say that I need also to include a battery on this. So in this case, I've already got a battery that's designed somewhere, but I don't want to place it yet, so I'm going to actually, instead of creating a new component, I'm going to go to the drop-down under Assemble, and I'm going to say Include. In this case, I have a battery pack that is located in this next folder over here, and when I do that, it drops the battery in the same way, unplaced in the assembly. Well, you're saying, oh, inside the drivetrain, I've probably got several components. I don't have to open an empty drivetrain assembly and insert several components there. I can simply grab that drivetrain assembly and activate it and create those components in there. So let's say we're going to have, inside of that drivetrain, I'm going to have a motor. Also leave that component unplaced. We'll browse over to the part file there. And then if you expand this out, you can see I've got a motor inside of there. I'm going to also place a, let's say, a sub-assembly of a gearbox inside of there as well. Then I'm going to place a sub-assembly for the chuck. And then I can go even further into that. I can activate chuck assembly, and I can go in and go as far as to insert components inside of there. So, chuck collar. Oops. And don't worry, I'm not going to go as far as to create an entire large complicated assembly, but this is just to show you how I can quickly and easily, we'll go back and activate our base assembly, create the entire assembly of an entire component here using this. And I messed up the trigger, so we need to actually delete that. We'll actually create a trigger.part. So part this time. Part, leave component unplaced. So the first thing we're going to do once we've created this entire system is now, since we're talking about skeletons, we're going to go back and we're going to create a skeleton to give us those placement space claims and the placement references where we're going to assemble things to. We're going to define all of that using our skeleton. So the first thing I'm going to do here is go and create, and this time instead of creating a part or an assembly, I'm going to pick a skeleton model, and I'm going to pick a standard skeleton model, and we're going to label this one drill underscore skell. And you'll find most of the time people consider this to be good working practice, that when I use a skeleton part or skeleton sub-assembly, motion skeletons or standard skeletons, that you use the same terminology of the components that you're basing the skeleton off of, but you make sure and put an underscore SKEL, which allows you to quickly and easily, from looking at your model tree, determine which of those components is the skeleton and that sort of thing. So I'm going to say drill underscore skeleton, and I'm going to click OK. And it's going to ask me, how I want to place this and all of that information. Again, I'm going to do a millimeter kilogram second part.prt. And notice that it placed my drill skeleton right directly at the top of my model tree. Even though I already created things, the skeleton parts are always going to be at the top. When I expand this out, you'll see there's nothing inside of it. I'm going to actually open this in another window and actually create the base for this drill. And we're going to do that using traditional modeling features, only instead of using solids, I'm going to use a lot of surfaces instead. So I'm going to first click extrude, and I'm going to extrude from the front plane here, and I'm going to put a simple circle here of diameter, let's see, 50 millimeters. And I want to complete my sketch, and you'll notice it automatically toggled to a solid. In this case, I want to make it a surface. And I want to extrude 100 millimeters in one direction, and I want to go to my side too, and I want to extrude 50 millimeters in the opposite direction. Notice the blue color indicating this is a skeleton part. Next, I'm going to come in and I'm going to add another extrude. This time we're going to extrude from the top plane instead, and I'm going to use our handy-dandy center and axis ellipse tool to start from the center, and I'm going to come out and we're going to give this, let's see, we want this to be, we'll say 45 millimeters long by 25 millimeters wide. So that'll give us a nice, somewhat ergonomic grip to it. Again, toggle this to a surface. I'm going to flip the direction the other way, and I want to specify, in this case, I want it to go 100 millimeters. While I'm in here, you'll notice that I've got two things. I've got these two surfaces that are intersecting with each other, and to show you a little something slightly off topic but very much related, I want to take these two quilts. So I'm going to select both extrude 1 and extrude 2, and I want to merge them together. When I merge them together, it's going to ask me which sides I want to keep, so I want to flip my arrows to designate the two different sides that I want to keep. I can also do that up here with the arrows here. Notice when I get the orange wireframe, or I guess the orange almost shading grid on the parts that I want, then I will complete the feature. You'll notice that now it trimmed out the other portions of that, and now this is one quilt that can be selected as an entire single quilt. Well, there's a few other things I want to do in here that I'm going to create placement references. First of all being I want to create an axis that goes through the center of this quilt, and I want to name this drivetrain, because that is going to be the axis that I'm going to assemble my drivetrain to. Maybe I want to put a plane offset from this out, we'll say 75 millimeters, and I will label that plane chuck, because that's what I'm going to assemble my chuck to. Then maybe I want to and put another plane down from the bottom. Let's see, we'll go from the top plane down 100 millimeters, and we'll label this one battery. And that's going to allow me to have a reference to assemble my battery to. And then we won't go and actually assemble the entire drill and create an entire drill from scratch. We only have an hour, so obviously that's probably not realistic to expect to be able to do that in this time frame. What we do want to do is I'm going to focus on the trigger. So we're going to put an axis in, and with that axis, datum axis tool selected, I'm going to also create a plane offset from this top plane down 50 millimeters, so I'll say minus 50. and I'm going to put my trigger axis through there and through this this plane here as well. And we're going to label this one trigger. And let's say, for example, let's change some of these around. Maybe I'm going to grab that battery, and I want to edit the outline of this battery. Oops, let's see here. Adjust the outline, not off of size, but off of reference. Now let's cancel out. I just made a mistake there. So don't do that. That's something that you don't want to do. I'm going to edit the definition. I'm going to go to my display. I'm going to adjust the outline based off of a reference, and my reference, I'm going to pick this surface to designate. We'll hold down Control. Maybe that's as far as I want that to go through there. Or my trigger, I don't want to be through the entire part. So let's turn on our axes here. And I want my trigger only to be through that portion of the assembly. So I can edit the definition of the trigger, display, adjust the outline based off of a reference, and I'm going to pick that same reference there. Again, tips and tricks. We try to show you a few cool little things spread throughout as well, so that if you're not necessarily interested in skeletons, you might still be able to learn a couple of other things throughout this as well. So now I'm going to have those things that I can come in and assemble there. So let's close out. Let's save this guy, and let's close out of here, and you'll notice that now I've got the skeleton that I created located inside my drill assembly. Well, I want to also create a trigger on this, and let's say, for example, I'm going to show you two different things we can do here, one of which being where I take an existing model and create a skeleton from that, and then I'm going to show you how to take a skeleton and create a model from that. So we're going to do something kind of that doesn't logistically make sense in this specific application. I'm going to create a part, or create some geometry. I'm going to create a skeleton from that geometry, and then I'm going to use that skeleton to actually generate part geometry. So I'm kind of taking the long way around to show you two steps. Just note that this isn't necessarily realistic of the way that you would do this in the real world, but I want to show you two pieces of functionality built into one. So the first thing I'm going to do is I'm going to go in and create a new part, and we're going to call this part trigger _ geometry. And I don't want to use the part template. I want to go in and use my millimeter again. And here I'm going to create a couple things. First of all, we know that we need an axis for our trigger, and we need the geometry to actually create the trigger. So I'm going to first drop an axis at the intersection between the right plane and the top plane. We're going to name that axis trigger. And then I'm also going to create an extrusion on the right plane. In that case, it actually turned the wrong way, so I'm going to just hold down Control and rotate this 90 degrees to the right. So just to verify that this all popped in correctly, let me turn my planes off for a second, and let me make sure my axes are turned on, and I'm going to pick trigger axis to make sure, there it is, it's horizontal, that's the way I want it to be. And I'm going to create some geometry. Just a simple 3-point arc. We'll start here, come down to about here, and we'll make it about like that. Now, I made it in millimeters. This is 77 millimeters off of the front plane. That's probably not to be desirable, but I'm going to show you another little trick here. I'm going to select all of the geometry. I'm going to go up to my Modify tool. I'm going to check the box that says Lock Scale, and then I'm going to come in and I'm going to say, for example, I want this top dimension here, and if I scroll up, I should see it highlighted right there. I want that SD4, in this case. I want that to be 25.4 millimeters off of the horizontal. And notice how it rescaled everything for me. So just like we always know, sometimes that when you drop that first sketch in, it comes in as 1,000 millimeters instead of 4 millimeters like you're wanting it to be. We can use that Modify Dimension tool to rescale things appropriately. And now I can come in and tweak these individual dimensions a little bit. Maybe I want this one to be not 19, but we'll say we want this one to be 25. And we want this other dimension here to be 75. So that's close enough. And here's something that I'll show you, another little trick. Because under my extrusion I have this currently selected as a solid, when I complete a sketch that does not contain a closed loop, if I go to my feature requirements, you'll notice not all ends have been explicitly defined. When I complete this sketch, I'm going to get a warning. There is no solid geometry in the model to intersect with this feature, therefore the sketch must be closed. If you continue, the feature type will automatically be changed to surface. this case, I want a surface, so that's what I want, so I'm going to click OK. If maybe I wanted to do a thickened instead, I could toggle that back to a solid, and it would automatically toggle to a thickened, let's say 3 millimeters thick. But in this case, I actually do want it to be a surface, and I'm going to say I want to do a symmetric extrusion of 25 millimeters wide, and that's going to be the geometry I'm going to use to create my sketch. I'm going to click OK, and you'll notice I have a purple surface. Again, in Creo, since Creo 1 came out, surfaces and solids show up in different colors. Solids show up as gray, like we're used to. Surfaces and quilts show up as this kind of purplish, I don't know, I guess my wife would probably tell me it's periwinkle. I'm not good with the colors, just like most guys aren't. But I have, I can tell right away this is a surface. So now this is the geometry I'm going to use to create my trigger. So I'm going to save this, and I'm going to close it. And I'm going to do something that is probably, I don't know if a lot of people would consider this good practice or bad practice, but it is something that I know I'm going to have to change the configuration option. I'm going to insert multiple skeletons inside of this drawing. So if this is a simple enough component that I probably would not need to do this in the real world. However, just to show you how to do this, I will go ahead and do this. And for very large assemblies, which I'll show you one here in a little bit, these will be multiple skeletons within an assembly will be very, very valuable to you. So you want to go to your File, Options, and under your Configuration Settings, when this pulls up here in just a second. Oh, no. Okay, so that's never happened to anyone else before, has it? Okay, so let's go in and we'll open this guy back up again. It wouldn't be a good demo unless we crashed Creo at least once. So let's retrieve, and fortunately, let's see if I actually, go back to my favorites. I did not save that assembly. So let's go in, and fortunately I do have another one that's located in here that is completed. Notice when I try to open it, I get an error telling me that I have an invalid, extra invalid skeleton component. So I need to, this is a good point to show you, if I go over to File, Options, Configuration Editor, I need to find this multiple skeletons allowed, which you probably won't have it. You'll type in multiple and click Find Now, and go find multiple skeletons allowed, and change this to Yes. And click Add Change. And then close. Notice that will allow me to put multiple skeletons within an assembly. Note that I personally have this listed under my favorites. In this, this current configuration I'm running, I have just 5 different favorites. Sketcher starts in 2D if you like the old Pro-E of snapping back to 2-dimension when you start a sketch. Whether or not I want to display tolerances, multiple skeletons allowed, show interference in sections, and auto add remove. So multiple skeletons allowed. I want to make sure that's checked to yes. No, I don't want to save over my config file. And let's open up that assembly again. So drill.assembly. And here you can see I actually have already created that skeleton. But what we're going to do here is we're going to toggle back over to that other assembly. Let's actually remove this trigger component from the assembly. And we'll notice that we have a trigger skeleton that's already located in here. We're going to create, we're going to delete that as well, and we're going to create a new skeleton part based off of that trigger geometry. So I'm going to come in here, and I'm going to create a new component, another skeleton model, standard, and we're going to call this one trigger underscore skell. Again, if you already have a trigger in there and you don't add the skell, then it won't allow you to create it twice, even though there's a difference between a skeleton model and a part model. You do have to make sure you name those two differently. That's why we put the underscore skell. Click OK. And I'm going to say copy from existing, and instead of importing geometry like I could do, one of the options is actually to browse over to that other trigger geometry that we've created and open that. In this case, we want to leave the component. We don't want to leave the component unplaced. We want to actually place the component. So I'm going to click OK to place this guy into the assembly. And I want to turn on my planes and my axes here. And I'm going to grab this axis here, and I'm going to assemble it to that axis there. Then I'm going to add a new constraint. I'm going to pick this here, and we'll open this in another window so it's a little easier. We're going to make that coincident with that there. Add another new constraint, and we're going to pick this front plane and this front plane here and get those pretty close to each other. So you're probably noticing, yeah, that's a very, very big trigger. That's probably not going to meet my design intent. Don't worry, we'll take care of that in just a moment as well. But now I've got a skeleton, two skeleton models inside of my assembly here. So I want to go into this trigger skeleton, and I want to actually create a new part. So I'm going to create another new part. This time a regular part. We're going to call this one trigger. And I'm going to browse over to my regular part geometry. And I'm going to leave this component unplaced as well. And I'll show you another method of doing this. Oops, I meant to leave that unplaced that way. So if I open this component and I go to copy geometry, I'm going to be allowed to reference that existing skeleton model. So I'm going to open that. This is probably in the other folder here. We want to open, it's probably in session, that trigger skeleton. So trigger skeleton.prt. And when I do that, it's going to ask me for my placement references. I want to place, the easiest way to do this is using coordinate systems. So I'm going to pick coordinate system, and then I'm going to pick, I need to turn my coordinate systems on using my in-graphics toolbar. And I want to pick the coordinate system of the skeleton and then the coordinate system of the component. And that should fully place the skeleton, or the component with reference to the skeleton. Then it's going to ask me to pick what portion of the skeleton I want to keep. Now, this is very important here. You want to uncheck the box that says publish geometry only. I want to turn that off, and I want to then select which portion of my skeleton I want to keep. So surface sets. I want to pick this surface, the trigger surface. I don't have any chains in here to pick. If I had some sketches that I wanted to bring over, I'd do that in the chain section. And then under references, I want to make sure I want to pick that axis for my skeleton as well, my trigger axis. So that way I have a trigger axis located in the part itself. And then I'm going to click OK. Notice now I have an external copy geometry feature in my model tree, and I want to use this existing geometry to create another, to create some solid geometry. So the first thing I'm going to do is I'm going to toggle over to quilts, and I'm going to pick this quilt here, and I'm going to thicken my quilt. And we'll say I want to give it a thickness of 3 millimeters. And then I'm going to complete that feature. Then I want to create an extrude based off of this front plane, and I'm going to do a circle. We'll say probably about 5 millimeters will do, or maybe we'll say 10 millimeters, a little bit bigger. And I want to extrude that circle to this surface. So I'm going to say to selected, and I'm going to pick the back surface of the model here. So that way I've got a good parametric definition that it's always going to go from that plane to the surface. And that way I can define the length of this based off of the existing skeleton. You'll notice that I've got my solid geometry, but then I've got this blue geometry on the front here as well. Probably wondering what that's all about. Well, let's go in here and let's grab my copy geometry and let's hide this out. And then I want to go under and say, for example, I want to go back to the existing gray color for that front surface as well. And then save this guy and close it as well. And now you'll notice this is placed over here. I want to now assemble this. This is one method of doing this. I want to assemble this based off of the existing axis. Or even better, in this case, let's remove that and let's base it off of the not the axis but the coordinate system of the skeleton that we created this from. So I'm going to grab my coordinate system here and my coordinate system here, and then it will remain tied to that skeleton at all times. Now notice once I do place this, you'll get that little graphical jagginess of those two surfaces that are different colors that are occupying the same space. And you're probably wondering, what in the world is this Brad guy doing? This trigger is absolutely horrible. This, no matter what kind of drill we're going to design from this trigger is not going to be usable. Well, let's say that my overall design person has the ability to edit the skeletons, but no one else does. So that way, he can come back in and change just the trigger skeleton. So let's say he'll activate the trigger skeleton, and let's turn on our features so we can see what we've got going on inside of the trigger skeleton. And I'm going to grab this one sketch in here, and I'm going to edit the definition of it. And let's say we'll bring this down from 25 to, let's say, 12.5. And we'll bring this bottom up here just a little bit. We'll drag it to about right there, so maybe drag it out just a little more. Somewhere about right there looks better. And then complete my sketch. And I'm going to then regenerate. Let me activate my base assembly first and regenerate. And you'll notice that the geometry that was created based off of that has now been updated appropriately to match what I did there. And I could go back and do more, making changing the width as well. But this allows me to come in and make pretty large design changes where I can activate the base skeleton and modify the depth of an extrusion, or the diameter of a sketch, and say from 1.5 maybe change this to 2 inches. This one was designed in inches. The other one that I was working on was designed in millimeters. And I can see that if I tie things appropriately to this, everything's going to update accordingly. So that's a very simple way to not only use skeletons as reference placements, which I have the planes located in here to assemble my battery to assemble my chuck and collar to. I've got my my axis through the middle to assemble my drivetrain to. I've got my trigger defined here. So that's my placement references. I've got my space claims. I can come in and I can use this skeleton housing. I can give this to one team and tell them to design the drivetrain, and it has to fully fall within inside the surface. Then I can give the same skeleton to another team and say, I want you to define my housing, but it has to fully fall on the outside of the skeleton. Now, obviously, it's going to be a little more complicated than that. Putting a motor inside of a drill, it's going to be a little more complicated than a cylinder, which brings me to another really cool thing that I can show you guys. I'm going to close this and erase all this and free up as many system resources as possible. And I'm going to open up another model that I've got under here under my favorites. I've got this mower assembly. And this is a company that uses Pro Engineer. This is a very large assembly that was built using skeletons. And I may or may not have enough RAM to pull this up and use it well, which I'm not going to make any modifications to. I'm just going to show you how this is built in the real world, how people in the real world use skeletons to define large assemblies and break it up into different groups. But I should have enough system resources to do that. So you'll notice here in just a second when my model tree refreshes, I did get a couple of errors. I am missing a couple of components that are not referenced in here, but that's okay. I've got this very large lawnmower assembly. You can see all the blue surfaces. Those are all of the skeletons. If I actually go in and open this skeleton part, then you'll notice in this case, notice that they have their part number. Instead of putting an underscore SKEL, they just put SK at the end of the part, so that's another methodology. You can see here are all the different portions of my skeleton. I've got where my seat's going to be assembled to, where my rear wheels and my axis are, the different frames. I've got my mower deck here. And let's say, for example, I wanted to go in and make an edit to this. I could come in as far as, let's grab this component here and locate it in the model tree. And that's going to give me, let's say, my frame somewhere right here. Let's grab this sketch, and I can edit the definition of this sketch. And you'll notice that I can change from 7.8 to 12. And then when I come back and regenerate this, you'll notice that my skeleton also got longer. You may not have noticed how short it was before, but I made it just about 4 inches longer. And then when I came in and regenerated this, you can see there's the difference in the skeleton. If I regenerate this assembly, it will grow to that location. Now I'll tell you from experience, if I try to regenerate this assembly right now, it will crash because I'm missing some vital components that the manufacturer didn't send over with the demo. But you can see this is a very, very large, very, very complicated assembly. It's got a lot of different components in it, and if we did this like a lot of companies I've worked with and worked for in the past, you'll have people making the excuses, well, I need to design the front tires, but I can't do that until we get the frame designed, and they can't design the frame until they figure out what the designation for the motor is going to be, how big the motor needs to be. Well, if I've got a skeleton, I can define exactly all of those references. Here's where the wheels are going to go. Here's where these wheels are going to go. Here's where you put the seat. And this can be modified later, but it gives us a starting point. So now I can have people come in and start designing the mower deck based on where it's going to fit in here. And you can do a lot more complicated things with this, even dynamic analyses of. There was a good demo showing mechanism analysis of how far the mower deck is off the ground with relation to how far this pedal is pushed down that raises the mower deck. And those get into some really cool things that can be done as well. So let's get all those out of my memory there to free up some system resources. And there's one more thing I want to show you, motion skeletons. So first of all, let's go in under my favorites here again, and we're going to open up a cool little mechanism I've got designed here. Now first, the first thing I want to show you is actually I'm going to go in and we're going to set our working directory over here so I can make sure and keep all these things in the right place. I'm going to create a simple 4-bar linkage using the motion skeleton. So I'm going to start by creating a new assembly. We're going to title this one 4-bar. And I'm going to delete the template, or not use the default template. I'm going to use my millimeter kilogram seconds, and I'm going to use kind of the same methodology, only instead of designing all of the components first and then coming back and defining all of the pieces that attach to, all the skeletons that attach to that, I'm going to start by designing my skeleton. So I'm going to pick my skeleton model. This time I'm going to pick motion skeleton. And here we're going to say 4-bar underscore SKEL. Click OK, and I'm going to browse in my working directory. Notice this time it's giving me the assembly, whereas the standard skeleton, instead of giving me the assembly, it gave me the part. This time it's going to give me assembly instead. And notice it drops right in there. I'm going to turn on my tree filters for my placement here, and I'm going to turn off all of that so I can see what else is going to go in here. So I'm going to start by I'm going to activate the skeleton, and I'm going to create a sketch on the front plane. So let's turn on our plane here. Let's grab that front plane. And I'm going to create a really simple 4-bar sketch. I'm going to start with my crank, rocker, and then the ground linkage. One thing that's important when I'm doing mechanism connections inside of a motion skeleton, and I'm going to be putting circles at all the locations to define the holes for my linkages, I'm going to need to come in here and place 2 circles at every intersection, because I'm going to use one of those circles for each of these linkages. So notice I'm coming in here and I'm making lots of circles at the corners, and I'm snapping them all to the same radius. And I'm going to say I want this side to be, we'll say, make it a nice round number. Nope, don't want to do that. Let's say 100, and we'll make this other link over here equal to 25. Make this one 150, and we will make this linkage up here 175. So now I've created my sketch. I'm going to click OK. Nothing special, just a sketch with some different circles on it. However, now I'm going to create, I'm leaving this activated. I'm going to create the other components inside of here. So I'm going to create skeleton models, and I'm going to pick, instead of standard, I'm going to pick body for my motion skeleton. The first one we're going to call ground underscore SKEL. I'll click OK. And I'm going to copy from existing. I'm going to go browse over to that millimeter kilogram second part file. And I'm going to click OK. And I'm going to pick for which part of this I want to be the ground portion. So I'm going to query select the bottom surface here, hold down Control, pick the circle on the left, the circle on the right, and I'm going to click OK. Notice at this point I've created a ground skeleton.prt. And let me turn off the coordinate systems as well to just simplify my model tree. I'm going to come in and do that all the way around. So I'm going to say skeleton model body. We're going to call this crank underscore SKEL. And I'm going to grab, this time I'm going to grab query select the left side here, hold down Control, pick the circle here. Because I've already picked one circle, there's only going to be one circle I can pick up here. And I'm going to go all the way around and do the same for all of these as well. So rocker 1 underscore SKEL. Make sure that's a body. So rocker 1 underscore SKEL. Okay. Okay. I'm going to pick, query select this top rocker link. I'm going to pick this link here. Notice I cannot pick the circle down here anymore. It's not highlighting because I've already selected both the circles there. I'm going to pick this circle over here. Then I'm going to do the same for the last component here. So skeleton model, body, this one's rocker 2 underscore SKEL. Again, copy from existing. I'm going to pick query select this line here, and this line here. So right now I've got 4 skeletons. Well, there's still nothing special about them. I just basically took that sketch and broke it into 4 pieces. I need to go back and make mechanism constraints, which I could have done this while I was creating this. And if you notice, let's zoom in on our model tree over here on the left. I've got my ground skeleton is a standard skeleton. My crank, rocker 1, and rocker 2 skeletons are all actually packaged. So the first one, the ground skeleton, is fully constrained. However, the crank, rocker 1, and rocker 2 are all packaged. You can notice that by the little icon there. So I'm going to edit the definition of this first crank skeleton here, and I'm going to click this update button here. It's going to give me a whole long list of lots of different references. And I want to create a pin connection, so I don't want to create a bearing, potential mechanism connections. I'm going to go ahead and delete that bearing connection. Then I'm going to click through here and find the one that gives me the references that I want for a pin connection. This one right here is the second one. That's the one I want. So I can come in and I can pick the other 4 and remove those. And now notice, if I hold down Control and Alt, I can drag that around like a mechanism. Now I'm going to come in, I'm going to do the same with all the other ones. I'm going to grab the rocker 1, edit the definition, update, and this gives me quite a few references as well. I'm going to pick, I don't want that one, I want the second one. So I'm going to pick the final ones here, remove those as well. And then I'm going to do rocker 2, the same thing, edit definition, click update. Here I have quite a few more references than the other ones, so I'm going to pick through here. I want to pick the second one's the one I want, so I'm going to go ahead and remove the first one. I'm going to click through, second, third. Okay, so I want this one here as well, so remove this one, and then grab all the ones below here and remove these. And then notice here, now that I've defined all my mechanism connections, I've got a working mechanism. So how do I actually turn this into real parts? Let's go back and let's activate our base assembly. I'm going to create another part, and I'm going to not pick skeleton model, but I'm going to pick part, solid part. We're going to call this one, we'll start with rocker 2, and click OK. And notice here, because of the method I've been using to create this, I have a couple other placement options down here. Not only leave body unplaced, but I have attached component to body. And I'm going to pick this rocker 2 mechanism here, or mechanism component, and click OK. Note that rocker 2 is now attached to this. If I go in and I edit the definition of rocker 2, I'm sorry, not edit the definition, actually open rocker 2 in its own window, you'll notice that the sketch comes in. So let's go to our front view here. The actual sketch that of the skeleton part came into the part using an external merge feature. Now I'm going to create an extrude on the front plane, and I'm going to use my project to grab different components here, and then I'm going to grab my circle tool and make another circle here and a circle down here. And then I'm going to use my line tangent tool to put the sides of my linkage on real quickly and easily. Then we use my trim tool to come in and actually trim out a couple of little sections here. Now, a couple of the cool things about Creo now, I get a shaded view automatically telling me where that's going to be. Let's change our dimensions ever so slightly. And then I want to give it a thickness of 5. Complete my extrude. Save the feature. Close it. And now notice I have a mechanism associated. I have one of the components of my mechanism that's created. Just like before, if I come into this existing sketch and I edit this sketch and I change this from 100 to, let's say, 75, and then I regenerate, you'll notice that my solid does update appropriately so that now I've got, again, a working mechanism. Now, why would you want to use this? Well, I've got a really cool little example here, and I'll just show you this to you really quick. I want to open up inside of here. I've got, inside my motion skeleton, I've got a cool little mechanism I built really quickly yesterday. A straight line mechanism. If you guys have ever seen one of these before, it's a, I guess in this case, an 8-bar mechanism. The ground counts as the 8th bar that allows the output of the mechanism to draw a perfectly straight line. So this has been around since the 1860s or so when this was designed, but one of those cool little kinematic wonders that you see from time to time. And I created this entire thing using that motion skeleton. I've got my ground skeleton, all my linkages here. Inside my, let's turn on my tree filters here. I've got one sketch that drives the entire thing. So if I edit the definition of a sketch, you can see there's my sketch. And then I can come back and modify, let's say, from 75 to, let's say, 80. No, that's not enough. We'll say, we'll modify this to 100. And then click OK, regenerate, and you can see that my mechanism drastically differs. So this allows us real quickly and easily to make pretty complicated mechanisms and have them defined off of very simple sketches without having to go in and define the location of each of these components separately. At that point, we're at 12:55. I'd like to go ahead and open it up for questions. If you guys have a question, feel free to go ahead and type those in. And then I have a couple minutes to answer questions. If you don't have any questions, then we can call it a day here. But at this point, I would like to open it up to you guys. While you guys might be potentially typing in questions, just note that here's my contact information, my name, email address, and phone number. Rosalinda is the one that is in charge of the webcasts and does a lot of our training as well. So if you have any questions specifically about training, you can go to our website, cdtplm.com, or you can go to to Rosalinda, and she can answer a lot of that for you. At this point, I don't see any questions. With that, Rosalinda, do you have anything you'd like to add?
No, other than Sarah is going to be transitioning into taking over the webinars for me.
Oh, good. Good for Sarah. Good for you.
Yeah,
less off of your plate and more on her plate.
Continue to send me, any questions, of course. But yep, she is going to be the woman in charge. So I would like to thank everybody for attending, and feel free to sign up for next week's webinar.
Yeah, and we will be doing these every Thursday from noon to 1. So if you would like to, if there's anything you would like to specifically see, I know we've gotten several questions. If there's anything specifically you would like for us to cover, we're always looking for suggestions. So feel free to shoot that to Rosalinda or myself, or I guess pretty soon we'll have Sarah's contact information up here.
Next week's webinar is going to be covering Creo Simulate 2.0.
Okay, and there are some cool things that have gone from 1 to 2 in that, so that'll be a good one. Also, if you guys would like to, these are being recorded and put on YouTube, so if you would like to go to our YouTube page that's located here at the bottom, youtube.com/user/customer-driven-tech, that will give you everything we've ever done in the last, at least since I started working here about a year ago. So if you'd like to see part 1 and part 2 of my webcast, those are located there as well. And with that, thank you for your time. We appreciate you guys taking some time out from your lunch to come in and watch us play around in Creo.